Okay, so let's talk about working through the mole and what that means. All right, if we're working through the mole, say we have our mole map here, just a really abbreviated version of it. We have volume, mass, and particles. Okay, working through the mole means you're given something other than moles. So let's say you're given mass, and you're finding something other than moles. So let's say you're finding volume. Okay, so that way you have to work through the mole to get to the answer. Okay, that's what I mean when I say working through the mole. Okay, so we're going to use our mole map fairly heavily here, just as a reminder on how we do this. Okay, these are two-step problems. Okay, and when I say two-step problems, again, I mean you have to do two conversion factors. So again, if we're starting with mass and we're working to volume, you have to calculate to moles first. Then the second step is calculating the volume. Okay, it's all done on the same dimensional analysis structure, so it shouldn't be, it's nothing really new. You're just adding a step to it. Okay, so let's take a first example. Okay, all right, so how many liters would 57 grams of CO2 occupy? The steps are the same. We're going to take what we started with, so 57 grams of CO2, okay? And immediately we're going to put grams of CO2 down there. Now we have to work through the moles, so this first one has to go to moles, okay? And if you remember back from the previous video, the way to get grams to moles is using the periodic table. Okay, so we're going to do that under here. So C, we have one carbon, and each one is 12.01 grams. And oxygen, we have two of those. Each one is 16.00 grams. Okay, so 12.01 plus 32.00 gives us 44.01 grams, and that's what goes here. Okay, now we cross out grams of CO2. Now we have moles of CO2. All right, so we've started here at mass, and now we've gone to the mole. So now we've got moles, and we're going to go down to volume. Okay, because that's what's being asked is liters. Okay, so again, 1 mole. All right, the number next to mole is always 1, unless you're given a certain amount of moles. And then the conversion factor for liters is 22.4 liters. Nothing changes mathematically. Nothing changes. We multiply across the top. So 57 times 22.4 divided by 44.01. Okay, and we get 29.01 liters. Okay, our moles divide out, and we are left with liters, which is what we're asked for. So there we go. Okay, that's the gist of how to do a two-step problem. Okay, you take it a step at a time, and it's no different than what we learned in the previous sections. Okay, so let's do another one. We'll draw a little abbreviated mole map here. So mole, mass, particles, volume. Okay, now there's one thing you need to keep in mind. Okay, let's say that we're going from liters to mass. We'll just go in the opposite direction. So how many grams is equal to, I don't know, 17.3 liters oxygen gas. Okay, now nothing changes. We're going to start with 17.3 liters because that's what we're given. Okay, immediately we have to put liters in the chamber below. Okay, in the next section at the bottom. So our conversion factor is 22.4 liters per 1 mole. All right, our liters divide out, and we're left with moles. All right, we immediately put moles in the next chamber at the bottom. Okay, and then what do we ask for? We're asked for grams of oxygen gas. Okay, you cannot just put 16 there. Okay, even though that is the mass of oxygen. That is the mass of one atom of oxygen. Okay, or 1 mole of atoms of oxygen. Okay, but oxygen gas is not just 1 oxygen, it is 2. Okay, so you have 2 atoms of oxygen. So each one is going to give you 16 grams per mole. So you have 32 grams per mole. Okay, remember, this is, even though it just says oxygen gas, this is a molar mass, okay, for the molecule or for the compound. Okay, so if there's a compound, now if I just said aluminum, yeah, you can put aluminum because aluminum can stand alone. But because oxygen gas is actually a molecule, you need to put the mass of the molecule. Okay, so moles divide out and we're left with grams. So when we do our math, go across the top, so 17.3 times 32 divided by 22.4 plus 24.71 grams of oxygen, of O2. Okay, let's do another one. We'll make our little mole map here. Okay, so our example, how many atoms of, let's say, aluminum are in a 500-gram of aluminum. Okay, so we have a 500-gram container of aluminum. How many atoms is that? Okay, so we're going to take 500 grams, which is what we started with. Okay, and we're going to put that directly in the next chamber at the bottom. When we look on our periodic table, aluminum is 26.98 grams per 1 mole. Okay, so our grams divide out. We're going to put moles directly in the bottom of the next chamber so they can divide out. All right, and then we're going to have particles. Okay, so we started here at mass. We went to the mole, and now we're looking to particles. So the number for particles, 1602 times 10 to the 23rd atoms. Okay, so now we're left with atoms, and we're just going to multiply across. So 500 times 6.02 times 10 to the 23rd divided by 26.98. That math, we get 1.12 times 10 to the 25th atoms. Okay, and that's how many atoms of aluminum are in 500 grams of aluminum. Okay, let's do one more, and we'll be done. Okay, so let's make our mole map again. We haven't done particles to volume, so much gas, sorry, let's say how much volume would be occupied by, I don't know, 2.9 times 10 to the 24th molecules of CO2. Question. Okay, so we're starting with molecules, so we're up here at particles. All right, and we have to go to the mole first, so we have to convert them to moles. So we have 2.39 times 10 to the 24th molecules. And immediately we're going to put molecules down here. So it's 6.02 times 10 to the 23rd molecules, okay, is equal to 1 mole. Molecules divide out. We're left with moles. So now we're here at the mole, and we need to go down to volume. Okay, so we have put our mole down here, and the conversion factor is 22.4 liters per mole. So our moles divide out, and we're left with liters, and that's what we want. So we have 2.39 times 10 to the 24th times 22.4 liters divided by 6.02 times 10 to the 23rd molecules, okay? Do that math, we end up with 88.93 liters of CO2. So it's quite a bit, okay? So that is working through the mole. It's a two-step process, okay? In the previous few videos, it's been a one-step process. We've taken what we've had, and we do one conversion factor, and we get our answer. Now we have a second step. So now we take what we have, again, do the first conversion factor to get to the mole, do the second conversion factor to get from the mole to the desired factor, or to the desired unit, and then we have our answer. Okay, so it's no different. You're just adding a step. All right, so that is working through the mole.